In this set of notes, you guys are going to be learning about empirical formulas. Before we get on how to calculate an empirical formula, let's first talk about what an empirical formula is. An empirical formula, by definition, is the lowest whole number ratio of the atoms in a compound. So for some compounds, the empirical formula gives you the actual chemical formula for the compound. In other examples, or in other compounds, the empirical formula is just going to give you the ratio of atoms in the compound. So for example, if I had a molecule, H2O2, okay, the actual chemical formula is H2O2, but I can see that the hydrogen and oxygen are both present in a 2-to-2 ratio, which can be reduced to a 1-to-1 ratio, so the empirical formula for this compound would simply be HO, one hydrogen atom for every one oxygen atom. There are two ways to determine the empirical formula for a compound. The first is determined from gram composition, and there are two pretty basic steps for determining this. The first thing you're going to be doing is, if you're given the grams of each of the elements in the compound, you're going to convert them to moles. So we've talked before about mole conversions, so it's going to be a very simple grams to moles. Once you've converted each of the elements into their moles, the second step is going to have you compare the ratios of the number of moles of each by dividing by the lowest number of moles. And so we'll see an example of that in a minute. So let's say that we want to determine the empirical formula for a compound that is made up of 10.17 grams of potassium, 3.50 grams of nitrogen, and 12.48 grams of oxygen. As we said, the first thing we need to do is to convert each of these to moles. In order for us to convert these to moles, we first have to determine the molar mass for each of these elements. So if we start with the potassium and we use our periodic table, we can see that the molar mass of potassium is 39.10 grams per every 1 mole of potassium. Okay, and we're going to set up a ratio now because we don't have 39.10 grams of potassium. We only have 10.17 grams. And so we're going to solve for x to figure out how many moles that is. If I cross multiply and then divide, I end up with x equaling 0.260 moles of potassium. I'm going to do the same thing for the nitrogen. Nitrogen has a molar mass of 14.01 grams for 1 mole. Again, we have 3.50 grams, so we want to figure out how many moles that is. We solve for x, and we will see that we have 0.025 moles of nitrogen. Okay, for the last one, oxygen, molar mass of 16.00 grams per 1 mole. We have 12.48 grams. We want to figure out how many moles that is, and when we divide, we end up with 0.780 moles of oxygen. Okay, so step 1 was to always determine the moles of oxygen. The moles of each of the elements that we have. Now what we're going to do is we're going to find the ratio by comparing the number of moles. Okay, if I look at the moles, I have 0.26 moles of potassium, 0.25 moles of nitrogen, 0.78 moles of oxygen. We're going to divide all of these by the smallest number of moles, and the smallest number of moles is the 0.25. So again, if I take 0.26 and divide it by 0.25, that's going to equal approximately 1. 0.25 divided by 0.25 is going to equal 1, and 0.78 divided by 0.25 is going to equal about 3. Okay, these numbers right here give me the ratios, and we now want to turn this into an actual empirical formula, so we're going to say our empirical formula is 1 potassium for 1 nitrogen for 3 oxygens. And so the actual empirical formula for this compound is KNO3. So when we write these empirical formulas, we write them like we normally would for any chemical formula. You're always going to write the elements in the order that I give them to you, and remember, we're not writing subscripts of 1, which is why we don't see a 1 next to the K or next to the N. Okay, there's another way that we can determine empirical formulas, and that's from percent composition. It's very similar to the gram composition we just did, but in these situations you're given percentages, so you know the percentage of a molecule or of a compound that is a particular element. The major assumption we must make when we determine from percent composition is that we assume we have 100 grams of the substance, which means 95% of the substance is the same as 95 grams of the substance. Once we make that assumption, we can calculate the number of moles, and then once again divide by the lowest number of moles in order to get our ratio. So let's see an example of this. In this example, we want to determine what the empirical formula for a compound that would be, that is 94.1% oxygen and 5.9% hydrogen. So again, this is percentages, but the assumption that we make is that we have 100 grams. So we're going to assume that this 94.1% is the same as saying 94.1 grams of oxygen, and this 5.9% is the same as saying 5.9 grams of hydrogen. Okay, now it's just like the problem we just did, where we're going to convert each of these to moles. So we'll start with the oxygen. Okay, we know that oxygen has a molar mass of 16 grams for 1 mole. Okay, based on our problem, we have 94.1 grams of oxygen, and we want to figure out how many moles that is. If we solve for x, we get about 5.88 moles of oxygen. We're going to do the same thing for our hydrogen, 5.9, excuse me. We're going to start with the molar mass of the hydrogen. And we know that the molar mass of hydrogen is 1.01 grams per every 1 mole. We have 5.9 grams over x, and if we solve for x, we divide it, we end up with about 5.84 moles of hydrogen. Okay, when we compare these numbers, we should be able to see that they are about the same, which means the hydrogen and the oxygen are in a 1-to-1 ratio, which means our empirical formula for this compound is simply OH, 1 oxygen for every 1 hydrogen. So again, the empirical formula is always the lowest whole number ratio of the atoms in the compound, and we want to make sure that we always take our masses that are given, or our percentages that are given, and convert them into moles, and then compare the number of moles in order to find the ratio.